most likely to shock the ward.
Shocking our,
I think.
Yeah, it's shocking our activities.
Yes, but it is a shock to try to understand what this does. But who might be shocked into receiving this award, right? It might shock you as to who won.
It didn't shock me when I saw the name, but here is the trophy.
And the IOCCC most likely to shock award goes to Yusuke Endo from Japan.
And here is the fun piece of code. Here it's a very zappy. That's the code. That's the entire piece of code. And it is an impressive piece of code here. And let's see what it does, right? If you end up running it, you get this pattern, this discharge pattern, from the inside out, and you can run it again, and you'll get a different set. If you sort of, and this is what this is honor of is this a scientist, Lichtenberg, who was one of the first people to sort of describe dielectric breakdown of electric field that builds up on insulating material and then finds random weak points and boundaries and produces discharge. He was really applied physics to stuff, and one of the things in physics stuff he talks about, like lightning strikes, and why the patterns of those tendrils going up to a discharge point, why it's in that shape, and why is it seemingly random, but in fact has there's some physics involved in this stuff. And give you another idea about this Lichtenberg, here's a case of a lucite block. And what happened with this lucite block was an accelerator was used to embed into it, electrons at very, very high energy. So you had a elevated charge inside this lucite block. At the bottom, a ground point, a ground rod, actually an ice pick with a grounding strap, was touched to the bottom of it, and the interior of it discharged. And when the current goes through lucite, it turns it from transparent to translucent, and you get this nice Lichtenberg type patterns there to show you the discharge there. And so Lichtenberg was able to describe the physics behind this dielectric breakdown, and so this code that Endo produced does exactly this. The center, there's a breakdown, and it's doing the physics of building these lines. It's using the ASCII graphics for both color and intensity to show you the sets in that small piece of code. Doing real physics and current flows there. There is a challenge, and that is so this Endo gave us a really nice monochrome amber yellow discharge. A challenge is to produce an alternate version of the source code that uses the ANSI 256 color code palette. The palette where the color, the spectral color and brightness represents the charge intensity. So turn it from a monochrome to a colored version of that. See if you can produce an alternate program that accomplishes that. So I will say congratulations for their 21st IOC winning entry. That's a world record, most number of IOC wins in the contest history, and they continue with a really marvelous thing in IOCCC29.